Hello, hi, good morning. So today we are going to discuss how to find area under the graph by using formula of integration. Okay, now we have two situations. Okay, if we have area under the graph like this, okay, when A lower boundary, B upper boundary are values of x. So to find area, we use integrate y with respect to x. Okay, if we have this situation when A lower limit, B upper limit are values of y, so then to find area is integrate x with respect to y. Okay, now let's do question from textbook, page 104, self-exercise 3.6. Find the area for each of the following shaded region. Question 1a. Okay, we are going to find the shaded region. So here we have situation, lower limit is 0, upper limit is 3. These lower and upper limits are the values of x. So therefore, we use the first formula. Okay, so area equals to ABA, lower limit is 0, upper limit is 3, y dx. So y is 3x minus x squared plus 2 dx. Okay, so here we have to integrate. So 3x squared over 2 minus x cubed over 3 plus 2x. Okay, substitute upper limit. So 3 over 2, 3 squared minus 3 cube over 3 minus 2 times 3. Okay, so minus lower limit is 3 over 2, 0 squared minus 0 cube over 3 plus 2 times 0. Okay, so then you press calculator, can find the final answer is 21 over 2 unit squared. Okay, then question 1b, we have to find area under the graph. Okay, now if you can see from the graph, we have two separate shaded region, the left and the right side. But for the first shaded region, lower limit is negative 3, 0. The second one, the second shaded region, 0 to 2. Okay, so then this lower and upper limit are continuous. Okay, so then we can integrate directly, okay, by using formula the first one, because value of lower and upper limit are values of x. Okay, so area is lower limit negative 3, upper 2 y dx. So y is 1 over 2x squared dx. Okay, so this one is 1 over 2 x cube over 3. Okay, so negative 3, 2. Okay, so then 1 over 6 upper limit is 2 cube. Okay, minus 1 over 6. Substitute lower limit negative 3 cube. Okay, so then the answer is 35 over 6 unit squared. Okay, now we move to question C. Find the area of shaded region. Okay, so now we have curve, the pink curve. So under the graph is 2y. Okay, so then values of lower and upper limits are values of y. So therefore, use formula the second one. So area is lower limit is negative 2, upper is 1, x dy. Okay, so x is y squared plus y minus 6 dy. Okay, integrate y cube over 3 plus y squared over 2 minus 6y. Okay, negative 2, 1. Okay, so you substitute upper limit. 1 cube over 3 plus 1 squared over 2 minus 6, 1. Okay, minus negative 2 cube over 3 plus negative 3 squared over 2 minus 6 times negative 2. Okay, so then the final answer is negative 33 over 2. Okay, but this is area. Then we just make it positive, which is 33 over 2. Actually negative because the position of the area of shaded region is the left side of y-axis. So then you just make it positive because area always positive. Okay, let's move to the next question, which is question number 2. Question 2a, the limits are values of x. Okay, so values of x right here. So we use formula, the first one, area equals to integrate y with respect to x. Okay, from the diagram, we have two separate area. Even the limits continuous, but we cannot integrate at once because the right area is above x-axis. Okay, and the left one is under x-axis, will give the negative value. Okay, so now find the limit first. Okay, so to find the limit, you can look at the function first. Okay, you can find the roots. Okay, so from this function, so you can find the root is 0, negative 3 and 4. Okay, so this one is negative 3, this one is 0, this one is 4. Okay, so the function we expand y equals to negative x, x squared minus 4x plus 3x minus 12. Okay, this one negative x squared minus x minus 12. Okay, equals to negative x squared plus, x cubed plus x squared plus 12x. Okay, so just now we agree that we are going to use the formula with respect to x here. Okay, and we have to integrate separately. Okay, so to find area, okay, integrate for the left side, for area at the left side. Okay, so you know that the value is negative, so just put modulus negative 2, 0. So y dx, so x cubed plus x squared plus 12x. Okay, dx. Okay, plus for the right side, maybe I can use different color. So 0, 4. So negative x cubed plus x squared plus 12x dx. Okay, so we integrate. This one become, okay, negative x power of 4 over 4 plus x cubed over 3 plus 12x squared over 2. Okay, negative 2, 0. Okay, plus this one same, negative x4 over 4 plus x cubed over 3 plus 12x squared over 2. So from 0 to 4. Okay, so then we just this one we can simplify. Okay, this one can simplify 6. This one 6. Okay, then we substitute upper and lower limit. Okay, so this one is negative 0, power of 4 over 4 plus 0 cube over 3 plus 6, 0 squared. Okay, minus lower boundary negative 2, so negative 2 power of 4 over 4. Okay, full. Okay, so negative 2 cube over 3 plus 6, negative 2 squared. Okay, plus, okay, this one, negative 4 power of over 4 plus 4 cube over 3 plus 6, 4 squared. Okay, minus lower boundary, negative 0 power of 4 over 4 plus 0 cube over 3 plus 6 times 0 squared. Okay, so then for this value, okay, this value is 0. Okay, so 0 minus this value is negative, oh sorry, is 17 1 over 3. Okay, so plus this one is 53 1 over 3 minus 0. Okay, so 0 minus, this one is negative, but we know that area always positive, you just make it positive. So this one finally 17 1 over 3 plus 53 1 over 3. So the final answer is 212 over 3 unit squared. Question 2b, find the area for each of the following shaded region. Okay, so to find the shaded area, the pink shaded area, you need to find the limit first. Okay, so then to find limit is the intersection point. So we can use simultaneous. So let's say this is the first equation, this one is the second one. So we use simultaneous, 1 equals to 2. 1 equals to 2. Okay, so x squared minus 4x plus 5 equals to negative 2x plus 5. Okay, so x squared minus 4x plus 5 plus 2x minus 5 equals to 0. So x squared minus 2x equals to 0. So then x minus 2 equals to 0, x equals to 0, x equals to 2. Okay, so right here is 0. Okay, then this one is 2. Okay, so find y. Okay, when x equals to 0, you substitute any y, 1 or 2. So let's say I substitute into 2, y equals to negative 2 times 0, 0 plus 5, y is 5. Okay, so when x equals to 2, y equals to negative 2 times 2, negative 4 plus 5 is 1. Okay, so this one 1, this one 5. Okay. Okay, to find area of shaded region, so shaded area. Okay, shaded area is this one, the shaded area. Okay, equals to trapezium. You can see we have trapezium minus area under the graph. Okay, area under the graph is this one. Okay, this is area under the graph. Okay, this one. Okay, the area under the graph. Okay, so for trapezium, okay, for trapezium, we know how to find trapezium. Okay, is 1 over 2. Base, okay, base, this one is 2. Height is 1, this one is 5. So, times 2 times 5 plus 1. Okay, minus. Okay, area under the graph. For this one, we choose the first formula because the lower and upper limits are values of x. Okay, which is 0 and 2. Okay, y dx. Okay, y we choose y1. Okay, not y2 because the graph here under the graph is the graph of y equals to x squared minus 4x plus 5. Okay, so this one x squared minus 4x plus 5 dx. Okay, so actually for trapezium, okay, for trapezium you can use, okay, sorry, this one you can use integrate from 0 to 2 y, which is the straight line, okay, which is negative 2x plus 5 dx as well. Okay, but I prefer use formula of trapezium. Okay, so then we find the value, this one 6. Okay, minus integrate first, x cubed over 3 minus 4x squared over 2 plus 5x 0, 2. Okay, this one we can simplify. So substitute upper limit. 2 cube over 3 minus 2, 2 squared plus 5, 2. Okay, minus this one 0, 0 cube over 3 minus 2 times 0 squared plus 5 times 0. Okay. Then we get 6 minus this value 14 over 3 minus 0. Okay. So 6 minus 14 over 3 is 18 minus 14. So 4 over 3 unit squared. Okay, question 2C, find the shaded area. So, find the limit first. Limit is intersection point. Then, we use simultaneous equation. So, this is equation number 1. Equation number 2, x equals to negative 2y. So, 2 into 1. Okay, so y squared equals to 5 negative 2y. So y squared plus 10y equals to 0. Y plus 10 equals to 0. Y equals to 0. Y equals to negative 10. Okay, when y equal to 0, find coordinate x. So x 0, when y equals to negative 10, x is 20. Okay, so y negative 10 right here. So this one is 20. Okay, so find the shaded area. Okay, so area equals to, area is this area. Okay. Okay, so for this situation, I think maybe you can use area this. Okay, this area. So meaning that triangle minus area under the graph with respect to y. Okay, so area of triangle. Okay, minus area under the graph. Okay, this one, the green one just now. Okay. Okay, so to find area of triangle is 1 over 2 times base times height. Okay, so is 10 times 20. Okay, so for this one, the lower and upper boundary values of y. So therefore, we use the second formula. So integrate AB x with respect to y. Okay, so A lower boundary is negative 10, upper boundary is 0, x. X is from this equation. We need to make x as subject. So x equals to y squared over 5. Okay, so y squared over 5 dy. Okay, so we just solve this. Okay, so this one 10, so 100 minus integrate. Okay, so integrate 1 over 5 y cube over 3. So negative 10, 0. Okay, so 100 minus 1 over 15. Okay, 0 cube minus 1 over 15. Negative 10 cube. Okay, so this one is 100 minus 0. Okay, minus 66. Negative 66 1 over 2 over 3. 2 over 3. Okay, so finally 100 minus 66 2 over 3. Okay, so the final answer is 100 over 3. Okay, unit squared because this is area. Okay, so now we are going to discuss question number 3a. If the curve y equals to negative x cubed minus x squared intersects the curve y equals to negative x minus x squared at points negative 1, 0, 0, 0, and 1, negative 2, find the area between the two curves. Okay, so to imagine the situation clearly, easier if you draw these two curves first. Okay, so now by using GeoGebra, I draw these two curve. Okay, these two graph. Okay, so the green one, okay, the green one is y equals to negative x cubed minus x squared, and the red one is negative x minus x squared. Okay, so we need to find the area between the two curve. Okay, so meaning that area between two curve is this one and this one. To find this shaded region, you need to find the area separately one by one. Okay, so to find this area, I have another graph here. Okay, I have another graph. Okay, so we find this area. Okay, so the value will be positive because at the top of x-axis. Okay, so then this one plus this one. Okay, the value will be negative because at the bottom of x-axis. Okay, so to find this situation, okay, this situation, okay, so you need to find area under the graph. Okay, so area under the graph, this one, under this graph. Okay, so this one, area under the graph, the value will be negative. Okay, and then finally you need to minus with the area under this one. Okay, so meaning that we have to find 4 areas. Okay, so let's say this is the first one, A1. Okay, this one is the second one, A2. Okay, the red one is the A3, and the purple one is A4. Okay, so we need to find one by one. Okay, so A1, okay, to find A1 first. A1, area 1 is integrate from negative 1 to 0 y dx. Okay, A1, we need to find the curve is quadratic. Okay, this one. So negative x minus x squared dx. Okay, so this one is negative x squared over 2 minus x cubed over 3 negative 1 0. Okay, equals to, we substitute, we get negative 0 over 2 squared minus 0 cubed over 3. Okay, minus negative, oh careful, okay, negative 1 squared over 2 minus negative 1 cubed over 3. Okay, we get 0 minus negative 1 over 6. So 1 over 6. Okay, so A1 is 1 over 6. Okay, makes sense because the value is positive. Okay, then find A2. Okay, A2. Integrate negative 1 0 function of cubic. Okay, so negative x cubed minus x squared dx. Okay, so negative x power of 4 over 4 minus x cubed over 3. So negative 1 0. Okay, so here negative 0 power of 4 over 4 minus 0 cube over 3. Okay, minus negative 1 power of 4 over 4 minus negative 1 cube over 3. So this one is 0 minus 1 over 12. Okay, is negative 1 over 12. So you put in the modulus. So 1 over 12. Okay, so A2 is 1 over 12. Then we are going to find A3. Okay, A3. A3 integrate from 0 to 1. Okay, so function of quadratic. Okay, so quadratic is just now this one. Okay, this one. So negative x minus x squared dx. Okay, so negative x squared over 2 minus x cubed over 3. So 0, 1. Okay, so negative 1 squared over 2 minus 1 cubed over 3. Okay, minus 0. Okay, 0 is negative 0 squared over 2 minus 0 cube over 3. Okay, so then this one is you get negative 5 over 6 minus 0. So modulus, so 5 over 6. So A3 is 6. Okay, finally we are going to find A4. A4 is integrate from 0 to 1, function of cubic. Okay, so A4 is integrate from 0 to 1, cubic function. So negative x cubed minus x squared dx. Okay, equals to negative x 4 over 4 minus x cube over 3, 0, 1. It will be negative 1, 4 over 4 minus 1 cube over 3. Okay, minus 0. Negative 0, 4 over 4 minus 0 cube over 3. Okay, so this one you will get negative 7 over 12. Okay, so you put in the modulus 7 over 12. Okay, so the A3 is 7 over 12. Sorry, A4 is 7 over 12. Okay, finally the shaded area. The shaded area is area 1. Okay, plus area 2. Plus area 3. Okay, minus area 4. Okay, so which is 1 over 6 plus 1 over 12 plus 5 over 6 minus 7 over 12. Okay, the final answer will be 1 over 2 unit squared. Okay, here is the solution of the whole question. Okay, so okay, right here we have A1. Okay, 1 over 6. Okay, A2 1 over 12. Okay, A3 5 over 6. Okay, A4 7 over 12. Okay, so to get the whole shaded region is A1 plus A2 plus A3 and minus A4. Okay, here we got question 3b, given that the curves y equals to x squared minus 4x and y equals to 2x minus x squared intersect at 2 points. Find the area of the region between the two curves. Okay, intersect at 2 point. You need to find that intersection point first. So by using simultaneous equation, you solve. Okay, so 1 equals to 2. X squared minus 4x equals to 2x minus x squared. So x squared minus 4x plus x squared minus 2x is 0. So 2x squared minus 6x equals to 0. Factorize 2x, x minus 3 equals to 0. Then x 0, x equals to 3. Okay, so find x equal the limit x equals to 0 and x equals to 3. So like previous question, actually easier if we sketch first the graph. Okay, so here I have that graph. Okay, like this by using GeoGebra. Okay, I sketch the two graph. Okay, so question number 2. Okay, so for y equals to x squared minus 4x is the green parabola with minimum point is the green curve, and parabola with maximum point for graph y equals to 2x minus x squared is the red one. Okay, so we need to find the area, the region between the two curve. Okay, the region between the two curve is this one. Okay, this area. To get this area, we need to find the area one by one or separately. Okay, so here I have another graph. Okay, so look at the graph. Okay, first of all, I need to find this area. Okay, so the limit is 0 to 2. Okay, so and the bottom one for this situation. Okay, for this situation, I need to find the limit first. Okay, so the limit is 0 to 3. Okay, so find this area. Okay, then finally minus this area. Okay, same. The limit is 2 to 3. Okay, so let's say here I have A1. Okay, this one A2. So this one A3. So we need to find one by one. Okay, so finally A1 plus A2 minus A3. Okay, so A1 first. So area 1, A1. Okay, integrate from 0 to 2. Okay, the function is the set curve. Okay, so 2x minus x squared dx. So 2x squared minus 2 minus x cubed over 3, 0, 2. Okay, so then substitute 2 squared minus 2 squared minus 2 cube over 3. Okay, minus 0. Okay, so this one, the answer is 4 over 3. To find A2, okay, to find A2 integrate from 0 to 3. Okay, so 0 to 3. The area will be, the value will be negative, and you just make it positive. Okay, 0, 3 function of green one. Okay, so x squared minus 4x. Okay, dx. So this one become x cubed over 3 minus 4x squared over 2, 0, 3. And you can simplify this before you substitute. Okay, here 3 cubed over 3 minus 2 times 3 squared. Okay, minus 0 cube over 3 minus 2 times 0 squared. Okay, so the value is negative. Okay, sorry, negative 9, negative 9. So just make it positive. So 9 units squared. Okay, so for A3, okay, integrate from 2 to 3. Okay, so from 2 to 3. Okay, what function? Okay, function for the red one. Red one is 2x minus x squared. Okay, so 2x minus x squared dx. Okay, this one 2x squared over 2 minus x cubed over 3. Okay, so from 2 to 3, substitute 3. So 3 squared minus 3 cubed over 3 minus 2 squared. Okay, minus 2 cubed over 3. Okay, the value is 4 over 3. This one 0. 0 minus 4 over 3 is negative 4 over 3. Okay, so negative 4 over 3 is 4 over 3. So 0 minus 4 over 3. Okay, so equals to 4 over 3. Okay, so A3 is 4 over 3. So this one is 4 over 3. Okay, just now A1 is 4 over 3. Same. Okay. 4 over 3 and A2 is 9. Okay. So previously we agreed that shaded region is A1 plus A2 minus A3, right? Okay, so shaded region. So therefore shaded region. So shaded region is A1 plus A2 minus A3. Okay, so 4 over 3 plus 9 minus 4 over 3. So the answer is 9 units squared.